Okay, so let's look at some flashcards. You need to understand these concepts if you want to get a 5 on the AP Statistics exam. So starting with the first one, it says describe a distribution. So remember, when we are asked to describe a distribution, we have to use what is referred to as SOCs. So shape, outlier, center, context, and spread. This one has it written a little differently. Just know that spread and variability are the same exact thing. So for shape, we're talking about skewness. We're talking about if it's symmetric. Outliers, if we see anything that looks like outliers, then we describe them as potential outliers. The center is either mean or median. Remember, mean if it's symmetric, median if it's skewed. And then variability or spread is standard deviation or IQR. Remember, standard deviation goes with mean, and mean goes with symmetric. And then IQR goes with median, and median goes with skewness. Okay, now the outlier rule. Remember, the outlier rule is also referred to as the 1.5 IQR rule. So in order to be considered an outlier, you either have to have a very small value, so Q1 minus 1.5 IQR, or a very high outlier value, so Q3 plus 1.5 IQR. Next one says, how can we use a graph to compare the mean and the median? So looking at mean and median, that has to do with the shape. So if it is left skewed, we know the median is going to be greater. If it is right skewed, we know the mean is going to be greater. And if it's symmetric, then it doesn't really matter if we use median or mean because they will be equivalent. The next one is interpret the standard deviation. So when you're asked to interpret that, just remember that standard deviation is the typical distance that the values are away from the mean. So if we look at this example here, it says the standard deviation of distribution A, the first dot plot, is less than the standard deviation of distribution B because there are more data points that are away from the mean or away from the center versus an A, all of them are going towards the center. The next one says how to describe the relationship between two variables. So it says when describing the relationship, we want to look at the following things. So direction, is it positive? Is it negative? Unusual features like outliers or influential values. Form, is it linear or is it curved? Typically it is linear, or we would refer it to as non-linear. And then strength, is it weak, moderate, or strong? Next one is comparing two distributions. So for this one, we use SOCs, again, SOCCS, that stands for shape, outliers, center, context, and spread. Here they're using variability instead of spread. The important thing here is when you are describing each of these things, we are using comparison words. You're not just saying, well, this is the distribution of A, this is the distribution of B. You are saying, well, A is similar to B by the following, or both of them are skewed right, or both of them do not have outliers, or the center on A is greater than the center on B. So very important, the comparison words. Okay, next it says how to find the mean, standard deviation, and 5-number summary using a calculator. So this is good if you're using the TI-84. Remember on Desmos, if we need to use the 5-number summary, we are going to go to add a function, and the function is going to be stats, S-T-A-T-S. And what that is going to have us do from there is create a list of the data, and then it will develop the stats for us. So 5-number summary is stats on Desmos. How to calculate LSRL using a graphing calculator. So again, these are the steps using the TI calculator. If we want to create a LSRL, remember we have to insert a table. Okay, then we have to export a custom regression line, and from there it will give us our y hat equation, our LSRL. Next says, what is IQR? Remember, IQR is the difference between Q3 minus Q1. So Q3 minus Q1 is all you need to remember for IQR. The third quartile minus the first quartile. How do I calculate the percentile or particular value in a data set? So it says order the data, count the number of values there are, less than or equal to the value of interest, and count the number of values in the data set. So for example, the percentile is going to be the number of values less than or equal to the value of the interest divided by the number of values in the data set. It says, for example, express the percentile as a percent. So the 58th percentile. Remember that it's different than 58%. Next one says interpret the y-intercept of the least squares regression line. So remember, the intercept is always the one that is not attached to x. We always say that this is interpreted by the predicted value of blank when blank is 0 if is blank. So those blanks are filled in with the y context, x context, and y-intercept value. So whatever that a value is in your equation. Interpret the slope of the least squares regression line. So the slope is always going to be the number next to x, and the interpretation of this is always going to be the same, just substituting in the context for the problem. So for every increase of 1 unit in x context, the predicted y context either increases or decreases by whatever that value is. So if your b value is positive, we say increases. If your b value is negative, we say decreases. Okay, next one says interpret the coefficient of determination r squared. The coefficient of determination gives the percent of variation of y context that is explained by the least squares regression line using x equals x context. So if it asks you to interpret this, this is the stem that you would always use. You're just, of course, going to substitute y context and x context, whatever the problem is about, into that sentence stem here. Properties of correlation R. So remember, correlation R is unitless. You will not give it a unit. It is always going to be between -1 and 1. Okay? It greatly is affected by outliers. If the direction is negative, then R is less than 0. If the direction is positive, R is greater than 0. And the closer R is to -1 or 1, the stronger the relationship is. The closer R is to 0, the weaker the relationship. So I would think the most important things here is that R is always between -1 and 1, and that the closer to those outer bounds, the stronger it is. The closer to the center, which is 0, the weaker it is. Next one is regression outlier. An outlier in regression is a point that does not follow the general trend shown in the rest of the data and has a large residual. So remember, if we had a dot plot, okay, and we had our predicted line, our y hat value, majority of the points should be near the line. If we have a point that is drastically outside of that, then we would call that an outlier. Okay, correlation R says gives the strength and direction of the linear relationship between two quantitative variables. So notice we have many graphs here. These graphs are representing what the correlation value would be. So for example, the very first one is approximately 0 because there is no pattern. The next one is approximately 1 because it shows a positive direction. The other one is going to be less than 0, so not exactly -1 because it's not a negative slope in a perfect sense, but it is going towards that. So we know it's definitely going to be less than 0. And then the last graph, notice how we see a curved pattern. So it's starting to go down towards that x-axis and then curve back up. When we have a curved pattern, then R doesn't apply. It only applies to linear patterns. Next one is high leverage point. A high leverage point in regression has a substantially larger or smaller x value than other observations. So again, this is going to be something that is going to look like an outlier. It's going to either be very high or very small on that x-axis, still away from that linear regression. An influential point in a regression is any point that, if removed, changes the relationship. Okay, outliers and high leverage points are often influential. So what this means is, let's say we had a list of data, and in that data, all the numbers were kind of around, let's say 50, and then we had this one number that was like 125. Well, if we were to average all those numbers together, the point 125 is going to drastically increase the entire relationship. It's going to create a big change. So that 125 would be an influential point, because if we were to remove that, then the average mean would decrease. Then it says, what is the difference between categorical and quantitative variables? Categorical takes on values that have category names or labels. And a quantitative variable is one that takes on numerical values for measured or counted quantity. So a categorical variable could be flavor of ice cream. Okay, when someone asks you what's your favorite flavor of ice cream, you're not going to give a number. You're not going to say 1, 2, 3, 4, etc. Quantitative would be when you're asked to measure your height. When you measure your height, you're not going to just say, well, I'm tall. You're going to say, well, no, I'm 5 foot 6 inches, or I'm 6 foot 9 inches. And then lastly, what is the difference between discrete and continuous variables? A discrete variable can take on a countable number. The number of values may be finite or infinite. So think discrete equals countable. So for example, a discrete variable could be the number of students in your class. You're going to count them, 1, 2, 3, 4, etc. A continuous variable can take on infinitely many values, but those values cannot be counted. When you think continuous, think the measurement, so like the height in the other example. So we could stop and say, okay, you're 5 foot 6 inches, but what if we converted that to centimeters? Okay, we might not have just one whole number value. It could end up becoming a decimal, like 40.56 centimeters.